algebra is a must-have. Second, a wise man once said, "It is all about the Benjamins." And a study looked at the correlation between grades kids get in high school and the amount of money they earn later. And it turns out that out of all grades, the grade a student gets in their first year of algebra is the most strongly correlated with the amount of money that child will make for the rest of his or her life. So this isn't just about an achievement gap. This gets into issues of equity and poverty too. And finally, whether you love them or hate them, we live in an era of high-stakes testing and standardized tests. And when we talk about, oh, America's falling behind other countries, we're talking about the math test. And guess which part of the math test keeps us up at night? It's the algebra. It's the word problem, stuff like that. So given how important algebra is, how do we feel about it as a country? We're terrified, right? So why? Why is algebra so hard? I went back to grad school and spent 8 years researching this very thing. To understand why algebra is so hard, you have to think first about what we tell students math is. So let's do an experiment. Let's pretend everyone in this room right now is 3 or 4 or 5 years old. We've just learned how to add. And so for all of you young boys and girls, math looks like this. And a teacher like me says, when I count to 3, I just want you to shout out the answer. All right, we're gonna do this. All right, kids, 1, 2, 3. Oh, fantastic, gold stars for all of you. And maybe the way you got it was you held up 4 fingers and then 2 fingers and then you counted the fingers. But what you just learned, even though I didn't tell you, was that math is a process and that your job is to compute the process and spit out a number. And as we got older, we added to the process. Subtraction, multiplication, 1, 2, 3. Easy. Beautiful. Division, solving for unknowns, right? 1, 2, 3. 7. Beautiful, you guys are great. And then many years later, we get into algebra. 1, 2, 3. What's the problem? The reason we can't answer that question is because it ain't a question. Yeah, it's true, there's still a process going on here, but algebra is the first time where math ceases to be just about a process and starts being about these abstract objects called functions. And an algebra teacher will ask his or her students, is this function linear or exponential? What is its image? Is it one-to-one or is it onto? And remember, if you're a child who still thinks your job is to compute the process, these questions aren't just
Okay, guys. So I want to hear from somebody now. That's a presentation on why he thinks algebra is hard. But from you guys, do you think algebra is hard before we even continue? And why? Why you think it's hard? What you find hard about it? I want to hear from somebody. Anybody. 2 minutes. You don't think it's hard? Yes, Miss, it is hard. Why? Why, Joel? Why? All right, guys. All right. Right. So as I was explaining before, algebra is really about abstraction because we have these big ideas in the world about how we want to build a house. So maths is in everything. So we have these big ideas about how we want to build a house and we need to know the arc length or we need to know this and that and that. And the only way we can really represent these big ideas are by using letters, right? So this is an example of a simple abstraction, right? So let's say we have a school bag and the school bag is $8,000 and they told us that we can get a discount of 30% on the bag, right? Not what would be the cost. That should be what should be the discount. Working with what should be the new discount, right? And so the discount would be the 30% of the 8,000. But in algebra, instead of just having 30% of 8,000, because each and every time that we go back, we might not be buying a bag, we might be buying a textbook that is probably $1,000. So then the $8,000 would be changing. But in order to consistently be working it out and getting it accurately and better, more precise, more efficient, instead of writing 8,000 and then changing it to 6,000 and then changing it to a different figure, because the 30% would be constant. The 30% is constant, right? So that's what they've set. That the discount is 30%. And the 8,000 is what would change depending on what we purchase. So algebra says no, that instead of always working out the numbers, always working it out like that, we can use letters and symbols to represent it. So instead of writing the 8,000, we could have written P, and that's how we create equations. So starting from the basic. So that's how we create equations. We say, okay, given P, given a price that is 8,000 and a discount that is 30%. And that's how we create variables and constants. So then the variable, the part of the equation that changes becomes the 8,000, and the part of the equation that stays the same is the 30%. So in the equations, we have variables and constants. So you get to that. Great. And then, right, then now we're going to look at basic algebra basics, right? So these are some things that are fundamental. I mean, even when you reach university, these come back and haunt you. So it's important to know. So I'm sure you've heard of BODMAS before, or BOMDAS. And what it really is saying is when we have some very complex equations, we have to follow a process. Somebody is saying something. Let me just check the chat. We have to follow a process. Right? And so when we have these complex equations, or you know those equations where it's a 5 plus minus, some of those equations tend to be the hardest equations. Even when you get to university, your book shuffles trying to wonder, should I add first, should I multiply first, what should I do, right? And so it's so important to remember this BODMAS. And what this basically says is that we should work with the brackets first, and orders has to do with like exponentials, square root signs, and those other things. Division and important to know, division and multiplication are on like the same level, as well as addition and subtraction. But more important to note is that this BODMAS equation is not used for every single equation, and you'll see why I said that. It's not used for every single equation, because some equation we tend to work from left to right. Okay, so let's go. We tend to work from left to right. Wait, give me a second. I think my screen just froze a while ago. Wait, give me a second to just come over. I want to show you an example to show what I mean. Let me just stop sharing. Yeah, after sharing. Right, right. So when we simplify equations, I was just saying that we typically go from left to right. If the operations, this is going to answer your question, the person that just asked the question. So when we simplify equations, we tend to go from left to right. If the operations are on the same priority, that's on the same scaling, the same preference that I just showed you. So if they're on the same, we'll go from left to right. So in that case, it would matter. It would matter if it's multiplication or division. So it's, if it's the same, so let's say we multiply by, if we have an equation where it's multiplication and then division, like this like this example right here, where I have division and multiplication, right? When you look at the bomb, that's why when you look at the bomb dash right here, you realize that the ordering actually says division and then multiplication. But that's not always the case. Why I say it's not always the case? Because it's it's kind of like it's on the same priority listing, that if you have both of them consecutively, if you have both, if you have them following each other, this doesn't matter anymore. So like this equation, we go from left to right, but we have division and multiplication sign. The division comes first and then the multiplication. But multiplication and division, they're on the same, we can say the same wavelength. And so we can just divide first and then multiply. But we have then we have some other cases where it kind of looks more rumbled like this, more, complex like this. And so I want somebody to guess and tell me how we would work this out. You can write it in the chat or you can unmute and tell me what you think we would do first. What you think we would do first? All right. So remember bod mass. So bod mass actually tells us to work out. Wait, let me see if somebody gets it. 6 times 25. Close, extremely close, extremely close. Yes, yes, actually, it would be 6 times 25. But more specifically, we try to solve the brackets first. So in all these complex equations that you'll ever get, especially in probably going further like university, it's the brackets first, right? So it's the brackets first. We try to work out the brackets first, and then after we find out where the brackets are and we try to simplify the brackets, then you can look back at the BODMAS acronym and find out what's next. So all right, I'm gonna aim to work out the brackets, but what next in the bracket do I work out? What's the first thing I try to solve in the bracket? So I see somebody said 6 times 25, and I get what they're saying, because first you're trying to simplify the brackets and then you go inside the bracket and then you realize that you have an exponent, the 5 to the square. So what he actually did, probably unconsciously, without even thinking about it, is, wait, yeah, what he probably did unconsciously without even thinking about it was work out the 5 square second. You worked out the 5 square second and got 25, and then you move straight to the multiplication sign first. So that's BODM. We don't have any division, so we went straight to multiplication and we worked out the multiplication, which would be 6 times 25. So that's the first thing that we finally get. And then after we get that 6 times 25, then we would work out the addition. So you realize that it's not a matter of, so we realize that it's not a matter of working out, we realize that it's not a matter of working out the multiplication before the plus that is beside the 7. So it would come out of the bracket. So even if we had a lot of other things going on in the bracket, we always try to work out what's inside the bracket first. Okay. So then we have, like, anytime I share the screen, the slides start to give issues, and I'm not sure why. Not sure why. I have to change it. Come back. Change it. Right. Right, so the solutions, so we say we try to work out, the brackets first, so that's when we did that, and then we try to work out the orders, or orders or others, or yeah, others, meaning the exponentials, like root sign and yeah, especially root signs and exponential. So 5 to the 2. So we write that out next, and then we multiply first. So that's how we got the 150 inside, and then we added the 3, and then that's how we resolve the bracket first, and then we, after resolving the bracket, then we start working on everything that's outside of the bracket, and that's how we get 160, right? So that's that for BODMAS. That's that for orders. But then that has to do with numbers, right? And I just said that algebra starts to incorporate letters instead of numbers, right? And so when we have letters now, we have a whole different set of rules to dealing with letters. So this is just a teaser. I have some other things, but for this one, I want to know if we understand the rules of combining this expression in to get one. What would we do first? And the BODMAS actually comes into this too, but it's just that it's with letters. So in this case, what would we work out first? In this case, what would we work out first? Somebody tell me. What would we do first? What would we do first, guys? What would we do first? Let me try to see something. Yeah. Right, 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 right. Okay, guys. So we're gonna try, right? So the 2, it's 2 times AB, right? And then we're gonna try, wait, people are typing in the chat. Let me see. Yeah, it's already connected, right? So we're gonna try to evaluate this first. Trying to evaluate that first, right? Then we realize, all right, we can cancel the 3's, pools, we can cancel the B, and cancel the B's as well. So what that leaves us with is 2AB plus 2A. So that's what I meant by you can still use, but you're still using BODMAS because you'd multiply first, because remember multiplication comes before addition. So we would multiply first. So right, so 2A plus 2B, because the 2 times the A. And then we realize that we can't combine these because it's different variables. So we have one in terms of AB and the next one in terms of A. But this one, so as I said, it's just the difference is just that this one has letters, right? Really, really. So for this one, what would we work out first? What do you think we would work out first? What would we work out first? Okay, so we'd work out, right, we'd work out the multiplication first. So we need to find out what is negative 2b times 2a. So that's negative 4. And we tend to, in algebra, we tend to write it in order of, the alphabet. So that's negative 4ab. And then we'll combine everything else. So you realize that we get 4ab plus 2ab. And then when we combine all of that, because everything is in terms of the same variables, they're all in terms of AB, then we realize that we just get 2AB. Okay. All right. Oh, tends to. Don't know what's giving me issues changing the slide when it's on sharing. I don't want to keep coming out of sharing just to change the slide. Don't know why. Anyways, I think it has to do with um okay, right. So we have some other rules in algebra. So we just saw how the BOD mass works with either numbers or letters. It's the same way we work with it. And then now we have some other rules in algebra where they're right here, where if we're adding, we know if we had addition plus addition, we get addition, negative, and negative gives us negative, that's adding. All right, plus and minus, and all of that. So then multiplication, we know that if we have plus and plus, we get plus. If we have minus and minus, if we multiply two negatives, then we get, right? And then for the negative, for multiplication, once there's a negative, if there's a negative and a positive, then we get negative. Right? So, right, so these are just some examples of working with negatives. The fact that 2 minus 3 is -1, we will see that. And so let's just go on something for a moment. Wait a second. All right, guys. So there's a game in the PowerPoint. When I upload it, you can just play that. It's gonna take some time right now. Are we seeing the slide? Because I'm realizing that there's some issues with showing the slides. Are we seeing it now? Okay. All right, Robin and Daniela. Or is it Daniel? Wait, let's see. Daniel. Okay. So then we have some algebra vocab that we must know and must understand. If we can understand these vocabulary guys from early, then it saves us a lot of trouble in the future, right? So then we have these terms. So this is an algebraic expression. And the only difference is an expression and an equation is that an expression is not equated to anything. It's a group of new numbers or letters, and it's not equated to anything. So the expression, the equation has the equal sign. And so a variable, that's the first term that we're gonna learn. So that's terms. Wait, the first vocab word is actually terms. Right? So the parts of an algebraic expression that are separated by the addition. So it's, the first term would be 8x, the second term would be 3y, and the next term would be 6x. And then we have a variable. And a variable just means varies. So you think of variable, you think of varying. So it's a symbol that represents an unknown number. So it varies just like the abstraction that we were talking about with the discount doesn't vary. So the store said, yo, this is the discount and it's not changing. But what changes, what can change actually, is the price of the goods, the price of those things. And in order to formulate equations and expressions, we need to know what part of it varies, what part of it must change. And the part of it that changes is often the part that we have more difficulty working out because we know that the constant part is that's always there. Okay. So factors is the parts of each term that are multiplied by each other. So the 8x, the factors of 8x is 8 and x because you multiply them to get each other, to get the 8x. And then 3y is 3 and y, and 6x, 6 and x. And the coefficient is just the numerical part of the term. So it would be the 8, the 3, and the 6. Okay. And then we have like terms, which is very important in knowing. And like terms meaning that it has the same variable, it has the same, right? So in this case, it's the same variable and it's raised to the same power as well, which is very important in working out some questions, because it's not only the fact that they have the same variables, but they must have the same power as well. So 8x and 6x, the x is a variable and they're both raised to 1. So x to the 1, right? And that's important because we're going to see, I think, in the next slide, that when we're doing addition, it must be like terms. It must be same variable and same power. But when we're doing multiplication, as we were taught an example before, when we do multiplication, it can be to a different power. So you can combine 8x and 6x square and that and those things. So then we have constant terms, which are typically just a number. It's there. There's no way of changing it. So the x we know is a variable, meaning that x could take on any value. I can just say, and that's how the abstraction comes about, because x can come about by me saying the discount, not the discount, in this case, the price is no longer 5. Right. So this is how algebra helps to make life easier, guys. When we have equations that we can change the x to 5, where I can decide and I can see what happens when the x is 5, and that's how they determine how determine like how much money to how should I price this if I want to make a certain profit and all of that stuff. You have to know basic algebra, and this kind of algebra, if you understand the core and the foundation, it takes you very far actually. And so right, so addition and subtraction, we know that like terms, as I was just hinting at, we can add and subtract like terms, so that's the same variable and raised to the same power, right? So we add this, so add this 8x and the 6x, and we get 14x. And then so when we add that, we get the 14x plus 3y, and we realize that 8x to raised to the second power plus 8x, we cannot add that. We cannot add that because that's two different, it's not the same term. It's not the same term raised to the same power. And then this helps us in factorization when we can find out, when we can group them based on the same variable. So then in this case, grouped based on AB, and BC, and BC. So then we get 5AB plus 3BC, right? So we can multiply and divide terms, right? So we can multiply and divide terms with unlike terms. So unlike, so we say like terms, it must have the same variable and raised to the same power, but unlike terms, it can just have the same variable but not raised to the same power. So in this case, we see where this we're multiplying 6AB and AC, not raised to the same power, or it's not even the same. It's not even the same. It's A, B, and AC, but we can combine it same way, and then we just multiply through and we get 12A squared BC. Does somebody want to say something? Any questions? Why? You want me to pause or go back? Oh, your internet is out. All right, sure, love. Tell me what's up. Tell me what's up. Tell me what's up. Tell me what's up. Talk to me. What's the issue, guys? Tell me what's wrong. What? No, why are you going to cry? I want to know. PM me. or send me a personal message if you don't want put it in the chat. I really want to know why that's concerning. I don't want you to cry. Anyways, it's a bit harder than what you did in 6th grade. You'll get it, no worries. You will get it. If you have questions, guys, please don't be afraid to don't be afraid to ask me. Oh, because I knew the name looked familiar, but I was wondering if a student was named that as well. Okay. All right. All right. What is the issue with these slides today? Not choosing not to change. Choosing not to change. I don't know why. All right, guys. So the last thing that will, well, time it, but the last thing that we'll do is if you have any questions based on the what we looked at, just that's the last. Any questions? Anything that you want me to just quickly clarify before we end? Questions, comments, anything that you don't understand. That we're gonna continue algebra tomorrow, so send me a personal message, let me know. I'm here to help. Something that you probably was struggling with in algebra before that I can probably come with prepared for tomorrow to explain or something. Let me know. You don't have to write it in the chat. You can, send me a personal message. Send me a personal message. Anybody? Anybody? Nobody? Come, guys. Any questions? Anything you want me to look at tomorrow regarding algebra? Or which area of algebra specific that you've been suffering with, you've been struggling with, or you just want general clarity? You want clarity, right? I guess nobody. So if that's the case, then it's nice. It's nice meeting you guys, Robin, Daniel, Natari. I didn't hear from you. Hello. You don't get when we do multiplication or division first. Okay. So the rule is, let me tell you. The rule is the general rule is that we do multiplication first, right? General rule is that we do multiplication first. But in the case where we have multiplication and division in the same equation, two of them behind one another, we have multiplication and division. If the division comes first, it's okay to do the division. Yeah, maths, sometimes you're gonna learn that eventually. Sometimes some exceptions in maths don't really make any sense, right? But but yeah, the general rule, right? The general rule is that we do the multiplication first. Okay, that's the general rule. But if it's the same, we take the traditional route by doing what's on the left first, doing it in order. Doing it in order. Okay. So normally, remember that, guys. Normally, we go in the order from left to right, but you realize some equations when it are so complex, I have multiplication, this, that, 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 that. So we go in order from left to right when it's on the same priority listing. So when it's multiplication and division, or when it's addition and subtraction, we go in order of left to right. But when it's just mixed all over the place, you use BOMDAS. And that's okay. So that's the end of today's session. I hope you guys understood. Yeah, if you don't and you look back on a question and you get confused or something, bring a question tomorrow and we'll discuss it. But for now, that's it. Nice to meet everybody. Bye.